Welcome to another video. In this video we are going to solve letter combinations of a phone number problem from the Leetcode. In this problem, given a string of containing digits from 2 to 9 inclusive, return all possible letter combinations that the number could represent. Return the answer in any order. So what they mean is each number in this phone number will represent a set of characters. 2 represents ABC, 3 represents DEF, and 4 represents GHI, and so on. So they will give what are all the digits for digits that have been pressed, and we need to return all the combination of strings which represents those digits. So whenever they press 2 and 3, that is the first example. So 2 represents to A, so the first letter can correspond to A or B or C. So that is what they are doing here. So if first letter is A, then second letter can be D, E or F. So that's why we are getting AD, AE, AF, and then everything will start from B, BD, BE and BF, and after that there is one more letter, that is C, CD, CE and CF. So that is how they are generating all the combinations. For the given digits, we need to return all possible letter combinations. So this is what the problem statement mean. And if we observe the constraints, digit length will vary from 0 to 4, and digits of I will be a digit in the range of 2 to 9. So I am going to explain this approach with a detailed diagram so that we can code the same solution before submitting in Leetcode. Let's consider one example, the first example. Given digits are 2 and 3. So we need to generate all possible combinations for these things. 2 maps to A, B and C. So for 2, these are the letters, and 3 maps to D, E and F. So when we are generating combinations using these things, first we will take this character and combine with all of these characters. That is, we will take A and combine with all of these characters to make a string of length 2, because given digits length is 2. So we will take A and combine with these 3, AD, AE and AF, and then we will take B and combine with all of these things, that is BD, BE and BF, and we will take C and we will combine with all of these things, that is CD, CE and CF. So these will be our letter combinations corresponding to these digits. So how we are going to approach this problem? What we will do is we will start with an empty string, and then we will check what is the first digit that is present in that given digits. So here it is 2. So for that 2, corresponding characters are A, B and C. So we can start generating all these things. So we will append A to our string, and when we come back from the recursion, and then we can consider this B, and then we can consider this C. So when we append A, then we will increment our index. So at the second index we have 3. So for 3 we have so many digits, that is D, E and F. So then we will start appending those values as well, AD, AE and AF. And here also we will start appending all the characters which are going to corresponding to this 3, that is DEF, BD, BE and BF. And here also we will append all the characters which are going to which are corresponding to these three, that is D, E and F. CD, CE and CF. So this is the approach that we are going to follow. The thing here is, initially here our I will be 0, this corresponding to this digits index. Since it is 2 and 3, this will be 0 and this will be 1. And here at this level our I will be 1. And observe the length here. This length matches with the length of the digits. So at this point we will stop our recursion or backtracking algorithm, and we will push all of these things to our answer array. So this is the overall approach. We will code the same solution so that it becomes very easy to understand. Let's start implementing the same solution that we have discussed here. So we will declare a vector of strings which will be used for storing all our answers. So I'm going to call that as combinations, and we need a map here. So when we map from 2 to ABC, it will be easier if we have a map. We can use an array as well. So using map becomes very easy. So we need to map from character to string. I'm just going to call this map as letters, and we need to initialize these letters for its corresponding characters. So for that we will be implementing a function which we are going to call it in our solution. So I'm going to call that function as init letters. What this function will do is, this function will populate this map. So letters of 2 will be ABC. So it is mapping character to string. We are just referring the image that is present on the left side. 3 corresponds to D, E and F, and 4 corresponds to G, H and I, and 5 corresponds to J, K and L. And 6 corresponds to M and O. Seven corresponds to P, Q, R, S. 8 corresponds to T, U, V. And 9 corresponds to W, X, Y and Z. This function will populate the map that we have declared here. So we are going to call this function init letters, and then we will call another function generate combinations with an initial index of 0, and then we need digits as an argument, and we need a current string initially which will be empty. We will start with an empty string, and finally we will return our combinations. The pending thing here is we need to implement this function which is going to update our answer vector, that is combinations. So we are going to implement the same function now. Generate combinations. So the first argument that we are going to get here is digit index. So this represents this index that we were discussing in our solution. Initially it will be 0, This will be used for getting all the characters from that map. So digit index, and then we will get digit string, and then we will get one more string, that is current string. And we need to check what will be our if our digit is an empty string, then we need to return an empty array. So we will first check that base condition. If not digits dot size, then we won't do anything, we will just return. Otherwise we will check if our current string dot size equals to digits dot size. If this is the case, then that means we are at this level and we need to stop recursion. We need to push this to our answer vector and we need to stop recursion. So combinations dot push back current string and return. If this is not the case, then we need to check for that corresponding index what are all the letters that we can get. So we can write string current letters will be equal to, now we can make use of this letters map that we have populated before. So letters of digits of digit index. So now we get all of these letters. Only thing we need to do is we need to call these functions recursively. So for int I equals 0, I less than current letters dot size I plus plus. So we should call generate combinations. We have already appended characters corresponding to digit index, so we need to call this with digit index plus 1 and digits will remain same, and we should append our current character to our current string. So current string plus current letters of I. So this is the only thing that is needed here. So let us submit this solution and check whether it passes initial test cases or not. Okay, I think we have a typo. Okay, this return type we didn't write. Okay, we have another typo. As you can see here, this solution is passing the initial test cases. Let us submit this solution and check whether it passes all the test cases or not. Yes, as you can see here, this solution is passing all the test cases. If you are interested in learning more about other data structures and algorithm related problems, please feel free to check out other videos from my channel. Thanks for watching this video.